So we did an example on the board of finding a side. Let's do an example with finding an angle, which is this one here, okay? So we want to find that angle there, so we just simply label up the triangle in terms of what we need. So if this is A, it's got to be little a, this is B, and this is C. And then we just use the formula, okay? So cos A has got to be equal to B squared plus C squared minus A squared, all divided by 2BC. By the way, that formula will be given in the formula booklet. That formula won't, okay? So either remember it or learn how to rearrange it. It's not that hard, okay? So let's have a look. So we've got cos of, well, we don't know what A is, so we're going to call it cos of X, is equal to B squared, that's going to be 30 squared, plus C squared, which is 40 squared, minus A squared, which is 46 squared, all divided by 2 times B times C, so 2 times 30 times 40. All right, cool. So I guess you could stick that in a calculator and work out what it is. Has anybody done that, just sticking that into a calculator? 80.79. 80.79.
Oh wait, that's after I did the inverse cosine.
Okay, fine. Did you do it before you did it?
Just 1 second. 4/25.
Okay, 4/25. Now remember, we want x, we don't want cos of x. So in order to find x, we're just going to have to take the cos inverse, okay? So we take the cos inverse of 4/25. What do we get? Is that the 80.79?
Yeah, 80.79.
Okay, cool. Degrees. Is that okay? Yeah, no dramas? Just sticking numbers into a formula. Now I think the hardest thing about this topic is working out when each one is going to be used. So this is the cosine rule. This is the cosine rule, okay? We've looked at the sine rule. It's just really working out when you should use each one, okay? So let me give you a few hints and tips. Can I rub this off now? Yep. Let me give you a few hints and tips of things to look for to give you a clue of when you should use the sine rule and when you should use the cosine rule. So let's have a look. So first of all, let's have a look at the sine rule. Now the definition of the sine rule, can anybody remember?
Sine A capital over A small.
Yeah, good.
And
Oh, sorry, don't
B
you?
over B sine C over C.
Good, sorry, I did it the other way around to what you said, but that's fine. So I'll do yours now. So it's going to be sine A over A equals sine B over B equals sine C over C. Okay? Now, you notice that by definition, this is just simply a ratio of the two sides. Okay? So in other words, this is the side, this is the corresponding angle. This is the side, this is the corresponding angle. So if I have a triangle that looks like this, it's a non-right angle triangle, okay? In order for the sine rule to work, I need an angle and a corresponding side, okay? And then of the thing which I want to find, I need either the angle or the corresponding side, okay? So I think of this as almost a matching pair, a matching pair. What I literally mean by that is that they literally match up. So I need a pair, so I need a side and the corresponding angle. And then of the thing that I want to find, that's got to be part of a pair. So I need one of these two things. So if I want to find this side, then I'd need this angle. Otherwise, it wouldn't work, okay? Likewise, if I wanted to find this angle, then I'd need this side. Again, otherwise it wouldn't work. Does that make sense? So the sine rule basically needs this idea of a matching pair. So I need one side and the corresponding angle, and then of the thing which I want to find, I need either the angle or the side. Does that make sense? So I need those two matching pairs. Okay? Is that okay with everyone? Yeah, good. Excellent. So, cosine rule. Let's have a look. So let's go finding the side first. So what is it? A squared equals?
B squared plus C squared minus 2BC times cosine A capital.
Perfect. And if I want to angle, so cos of A equals?
Negative B, is it?
Not quite, because you'd end up dividing through by the negative there. So it's actually...
A squared minus B squared minus C squared.
Not quite. Just double check that. Should be that. Yeah, just check that. Okay. So let's have a think. Let's have a think. Okay. What do I need here? What do I need here? Well, I definitely need, so if this is the angle, Okay, I definitely need the side either side of the angle. So if this is the angle which I'm interested in, I need this side and this side. Okay, and then effectively these two things just pair up. Okay, so I need one of these two things in order for the cosine rule to work. Okay, so you notice for the sine rule, I don't need all three sides. Okay, I don't need all three sides. I can get away with just two of them, and I don't care about this side. Whereas with the cosine rule, I definitely need each side of the angle, which I'm interested in, and either I'm given that or I want to find that. Okay, and again, I need to be given one of these two things there. Is that okay? Yep. Any rules? Any questions? No? There is one final little formula which I want to give you, which I have shown you before, okay, which is the area of a non-right angle triangle. So very quickly, okay, how do I find the area of a non-right angle triangle? Let's say that's A, that's B, and that's C. How do I find the area of a triangle ordinarily?
Height, 1/2 times height times base.
Perfect. Half times base times by height. Okay. Now you've got to be careful here. You've got to be careful because this height has got to be the perpendicular height. Yeah. Happy? So I'm just going to chop this down there. That's my H. That's my H. Okay. Now I forgot to label up my side. So if that's A, that's got to be little a. And if that's B, that's got to be little b. So let's have a think about this. Let's have a think, right? Remember this is a right angle. I've got my base. My base is B. My base is B. Happy with that? My height, in this case, is H, whatever that is. Okay? And I've got to times it by half. So in other words, the area of my triangle has got to be half times this base times by the height, but it's the perpendicular height. Okay? So my question is, how can we find the perpendicular height? Well, actually, that's really easy. Because have a look, I've got a complete triangle on the right-hand side. Could have used the left one, could have used the right one. Okay, so let's have a think. If I want to find H, this is effectively what I have now. This is C, this is A, and this is H. How could I find H? What ratio could I use here? What trig ratio could I use? Sine again, yeah? So I'm saying sine of C is equal to H over A, which means that H, remember the H is the perpendicular height, is just going to be A sine C. Do you see that? Just rearrange it. So therefore, if I stick this in here, I'll be left with half times B. B, remember, is my base. Okay. And instead of writing H now, I'm going to write A sine C. And of course, because I'm multiplying loads of stuff together, I'm just going to tidy it up. Makes sense to write it in alphabetical order. So it's going to be half times A, or I could say half AB, I guess, sine of C. That's my area. Okay? So you notice with this one, in order for this one to work, let me get rid of that. In order for this one to work, I effectively need an angle, let's say that angle there, and I need the side which is either side of that angle. Okay? So if I want to find the area of a non-right angle triangle, I need the angle and I need the two sides which are either side of it. Does that make sense when you use each one? Yeah? Okay. So can I ask you then to carry on and have a look at some slightly more complicated questions? So from question 113 onwards. These questions onwards are going to be using combinations of these three different rules that I've given you.